everybody, I'm Divina, and today as a part of our DSA playlist, we're going to be looking at arrays. And in specific, we're going to be looking at the sorting algorithms that we can apply on arrays. So before going on to the algorithms, let's try and understand what is sorting and why it's important. So sorting is basically arranging data in a specific order. Now this order can either be ascending or descending. And the manner in which this ascending or descending is determined is also a factor. That is, it can be based on the numerical value, or it can be based on the lexicographical order, or any other parameter that you would like. And why is sorting important? Because we tend to deal with large sets of data, and unless they are ordered in some form, it is very difficult to handle the data and make sense out of it. So by sorting it, we optimize our search to a very high extent. And also when a user is reading some particular information, it's better to present it in a sorted manner because it is easily readable. Now let's move on to the first algorithm that we have, that is bubble sort. Bubble sort is also called as sinking sort, and it's one of the most simplest sorting algorithms. It goes through the array and it sorts the adjacent elements, and if they are not in a correct order, it swaps them. And in this manner, it sorts the entire array. So this is bubble sort, and before we proceed to the other sorts, let's first look at the demonstration of each sort. So here we can see in bubble sort, the code for bubble sort is given over here. I've written it. So in the bubble sort function, we are passing the list, and iter_num is each element of the list, and it's going from the list, from the range len of list to the -1, that is, it's going in the reverse order. So for in IDX in range of iter_num, that is, we are having another for loop over here with the range as iter_num from the previous for loop, and we are comparing the two elements of the adjacent elements of the list. So we are assigning the temporary value to the element with the lower index, and if the element with the lower index has a higher value than the element of the higher index, that is, let's say we have a list in which we have 8 and 2. So obviously 8 has index 0 and 2 has index 1, but 8 is greater than 1. 8 is greater than 2. So because of that, we need to do a swapping so that 2 comes before 8 in the list. So that is what we are trying to do over here. We're assigning a temp variable, and to that we are assigning list of the lower index, that is 8, and then we are swapping them. That is, instead of 8 and 2, now we have 2 and 8. So the first two elements are at least sorted. And then this process is repeated multiple times until the entire array is sorted. So we can see over here, we're giving an unsorted list over here, and using bubble sort, we're finally printing the sorted list. Now let's move on to the next sort. So the next sorting algorithm we are looking at is merge sort. So merge sort is a very efficient algorithm and has good time complexity. So what it does is it divides the array into two halves, and then it sorts them and then combines them. So this is what happens in a merge sort, and we'll understand better using code. So let's go through the code for merge sort that we have. So first we are defining a function called as merge sort, and we are passing the list inside, that is the unsorted list. And then what we are doing, we're checking if its length is less than 1, because then there is no sorting to be done if it has no elements. So then we just return the same sorted element list, and then we're finding the middle. That is, what we're trying to find is the length of the unsorted list divided modulus floor division by 2. So we'll get an integer value, and then left list is we're finding the list which is to the left of that middle value that we have found, and then right list is the list part of the list which is in the right side of the middle value that we have found. So then what we are doing, we are passing the left list inside the merge sort, and then we are assigning it to left list. And then right list, we are doing the same thing. We're calling the merge sort function and passing right list as a argument. Then we're finally returning the merge of the left list and the right list. So we can see over here what merge function does. So merge function, it takes both left half and the right half, and then it has the final list called as res or result. So it checks first, there's a while loop that keeps on running. So if the length of, as long as the length of the left half is not equal to 0 and length of the right half is not equal to 0, the loop keeps on running. So if left half of the first element of the left half is lesser than the first element of the right half, then what happens? It appends the first element of the left half to the final result list. And then it does is left half, it removes the first element. And then because this process needs to be repeated, right? And we can't have the same element being appended again and again. So it needs to be removed. Then if that is not the case and the right half of the first element of right half is greater than the first element of the left half, then we proceed on with the else condition and what is given over here. That is, it appends the right half. And then the right half, the first element is removed. So then we can proceed to the further elements. And this process is repeated multiple times and then finally sorted. So if the length of the left half is 0, that means the result is we have to add the right half. Otherwise, we have to make sure that the result, we have to add the left half. And finally, we will be returning the result. So basically what we're trying to do, we're trying to reduce the load on the system as well as the time complexity by dividing our array or list into two different halves, and we're performing sorting. So that is what we are doing over here, and finally we get the sorted array. The next sort we're looking at is insertion sort. So insertion sort, first, the basic principle behind insertion sort is finding the right index or the right place for an element. So what we do first, in the beginning, we compare the two elements and then sort them by comparing them. And then what we do, we pick up the third element and we find its correct position among the previous two elements. So suppose we have 3, 1 and 2. So we look at 3 and 1 and we realize that if they are not sorted, so we make them 1 and 3. And then we have a 2. So then we have to put 2 in this between 3 and 1 or after 3 or before 1, wherever, based on the correct position. So because 2 is lesser than 3 and greater than 1, we put it in between. So that is what we do. We try to find the proper position among the previously sorted elements. So in this way, we go on and we add more elements to the sorted list, and finally, we have the complete sorted list. So we can see the code for insertion sort over here. We are passing the input list and we are running a for loop. So this loop goes from 1 till the length of the input list. That is the last index. So we are also assigning a variable j, which has the one value less than I, because we're starting with 1 and not 0 over here. So the next element would be the input list of I, that is the second element, and the first element will be j, input list of j. So while input list of j is greater than the next element, that is when we are comparing two elements, where as long as the second element is greater than the first element is greater than the second element, and the j is greater than equal to 0, that is the index is greater than equal to 0, we compare the two values of the adjacent values of the array. So that is j plus 1 will give you I and input list of j. So j is basically the element with the lower index, and j plus 1 is the element with the higher index. And if we assign it in this manner, and finally what we do, we reduce the value of j by 1. And then we have the input list in which we are assigning the j plus 1 as the next element. So what this entire thing is basically doing is finding the right location or the right index for the element, for each element. So we are going on sorting the list, and finally we get a completely sorted list. First we're sorting the first two elements, then we are sorting the first three elements, then when the fourth element comes, we again sorted by finding the correct place among the previous indexes, and so on we go until the entire list is sorted. So in this manner, we are able to sort the entire list and get the correct output. Now we're going to be looking at shell sort. So shell sort basically involves like sorting elements even when they are like far away from each other. That is, they're not adjacent elements. So we sort a large sublist of a given list and then go on reducing the size of the list until all the elements are sorted. So I think we'll get a better idea when we look at the code for this because the wording seems to be a bit confusing. Let's look at the code of shell sort over here. So we're passing the input list and we are defining gap. Gap is basically the length of the list, floor division of 2 so that we get an integer. And so if the length of the list is 10, it will be 5. And they'll be running a while loop as long as the gap will be greater than 0. That is, the while loop is running half the length of the real loop, right? So then what happens is for I in range gap comma length of the list. So if the length of the list is 10, it runs from 5 to 9. Then temp, we're assigning a temp variable over here and we're assigning it to the ith index of the input list. That is, it starts from 5 and then it goes 6, 7, 8, 9. And j is equal to I. We're assigning defining another value j, and then we're going into a while loop. So while loop, what's happening? We are checking if j is greater than gap. If it is greater than gap, and there's another condition that needs to be met, that is the input list of j minus the gap should be greater than temp. So if both the conditions are sorted, are true, then what we do is we replace input list of j by input list of j minus gap. So then what happens once we get out of this loop, we finally give that input list of j is equal to 10. And then we modify the gap value so that the loop doesn't run infinitely. We give gap is equal to gap floor division 2. So this way what happens, we go from each, we sort like a sublist of the list and then we keep on sorting the entire list until the entire list is sorted. So we take a portion of the list and then we sort it and then finally we end up sorting the entire list. So then as you can see in the result, we finally get a completely sorted list. Next, we're moving on to selection sort, and in selection sort, what we do, we find the minimum value in the list. So if the list has 10 elements and the minimum value is 1, we first find 1, and then we move it into a sorted list. Then we find the next smallest element, and then we find, and then sort it. So this way, what happens, the next element entering the list is compared with the existing elements, and then it's placed in the correct position. So finally, what happens, all the elements of the unsorted list are then sorted. We can see in selection sort over here, we're inputting the list, and then for index and range of len of, it's running as the loop is running as many times as the length of the list. Then we are finding the element with the minimum index, minimum value. So then we find for j in range, we're running a loop for that. So I index plus 1, and it's running till length of the final index, right? So it's running from, let's say, if index is idx is 0, then it's running from 1 to the len minus 1. So then we're checking if input list of minimum index is greater than the input list of j. So j is obviously, we have a second for loop, j is taken from there. And if actually the minimum index is greater than the input list of j, then we are assigning the minimum index to j. So then input list of idx comma input list, we are exchanging the values basically. So the index of the element which is placed in index of idx is given the value of the element which is placed in minimum index, and the vice versa. So this what happens, we go on sorting the list. First we find the minimum index and we sort it, and we go on sorting the entire list. So this is basically selection sort. And selection sort is also quite efficient, is currently that's what everyone is preferring. Also selection sort, many people are preferring, then it's a new kind of sort. So with this we come to the end of our presentation on the different sorting techniques. As we have given the codes, we'll also be attaching this Google Colab sheet in the description below, so you can look at that and you can practice it, and you can look at the different algorithms and uses of the different sort. Thank you so much for your time.